Okay, let's work through the practice test together. Our first question wants you to describe the rule for multiplying powers with the same base and give an example. And then also to describe the rule for quotient of powers with the same base and give an example. So the rule for multiplying powers, you could call it the product of powers or the product rule of exponents, both talking about the same thing. Saying that if you multiply two powers or powers with the same base, you add the exponents. That's all we're looking for the rule, is that if you're multiplying powers with the same base, you add the exponents. So the key words are multiply, same base, and add the exponents. All of those pieces are required for this to be a correct answer. You can't just say if you multiply powers, you add the exponents, because having the same base is key. Okay, 2 to the third power times 3 to the fourth power doesn't become 23 to the 3 plus 4. That's not how it works. It's got to have the same base for this whole thing to work. Okay, so each part is very, very important. Now, as for the example, you can use algebra, you can use or variables, you can use numbers. You could have 2 to the third times 2 to the fifth equals 2 to the eighth, or x to the second times x to the third equals x to the fifth. Okay, either way is okay. So for B, describing the rule for quotient, same type thing, except now we're dividing. If you divide powers with the same base, you subtract the exponents. And when you're looking for your example, you can use variables. Okay. Or you could use numbers. Either way, you want to show an example of that property. Number 2, describe power of a power. This is where if you have a power raised to a power, multiply exponents. For example, x to the second power all to the third power equals x to the 2 times 3, which is x to the sixth. That would be an example. Or you could give an example with numbers. Either way. Identify the base and the exponent. My base would be n. My exponent would be 4. That's it. Just label each part. Okay, now we start simplifying. Definitely show the work Because on a test or a quiz, your brain is going to have a natural level of stress, and trying to have it calculate too much creates silly mistakes and errors that you look back on and wonder what you were thinking. So write out the work. Writing this one little step here will help your brain organize and focus and see that the answer is x to the second power. Trying to calculate things in your head, our brains start doing crazy things on quizzes. Okay, another option for this is you could have simplified this negative exponent and turn that into 1 over x to the third times x to the fifth. And then once you multiply, you get a fraction, and you can use your quotient property to subtract and get x to the second. Either of those methods gets you the same exact answer. It's just whatever path you want to take. Here, this is a simple one. We have the quotient property. It means I'm dividing the same base. I can subtract my exponents, and you get x to the fourth power. Number 6, remember that this 2 is not to the fifth power, just the n. This is our base. 2 is separate, and if I wanted to put an exponent, it would be a 1. Again, over on this side, the only way the 3 would be squared is if it was in parentheses. So it's really 3 to the first power, n to the second. So what I would do is I would rearrange, I would use the commutative property so that my common bases are together and my numbers are together. Now remember, this is all multiplication. Even though you don't see the symbol, 3n is 3 times n. I can commute if I have all multiplication. So 2 times 3 is 6. N to the fifth times n to the second is n to the 5 plus 2. And you get 6n to the seventh power. Number 7, don't forget, this just means multiplication. The 24 is not to the 11th, just the m. It's its own separate base here. In a situation like this, you can imagine separating my numbers and separating my m's. This is just like saying I have 24 over 18 times m to the 11th over m to the 5th. This is the exact same thing. 24 times m to the 11th over 18 times m to the 5th. It's just that I separate them so that visually my brain can focus on each at a time. So I would look at my fraction and I would simplify. I can divide a 6 out of each, and I get 4/3. Now my m's, I have the same base. I can subtract my exponents. So I get 4/3 m to the sixth power. Don't overcomplicate these. You know the math. You know that this is 24 times m to the 11th and 18 times m to the 5th. And just like on number 6, where I multiplied my 2 times 3, on number 7, I can look at this 24 divided by 18 as its own number to simplify. Number 8 is an example where hopefully you did not overcomplicate the situation. Anything to the 0 power equals 1. 1 times 1,000 equals 1,000. Crazy simple. Number 9, I have a negative exponent situation. This is bad. This needs to become 3 to the positive third power. But to make it become the positive, I need to move it from the numerator or the denominator to the numerator. I don't need to put anything in the denominator because it would be a 1 anyway. That's it. If you wanted to continue simplifying it down, you could get 27. But it would be okay as 3 to the third. Number 10, we're starting to ask which expression is equivalent. Honestly, your best bet is to go through each option and simplify and see which one matches up. This is a power to a power, so we multiply our exponents. Well, I can already tell I want my answer should be A, but I would continue and go through each one, because what would happen if on the first one you make some sort of mathematical error? If you go through and you simplify each of these, if you get 2 with the same answer, then you know you made an error somewhere. So it's just a way to just double check yourself. So for B, I subtract my exponents. 10 to the negative fourth, not even close. On C, if I multiply, I add my exponents. Nope. And for D, negative 10 to the negative eighth. Oof. That's going to become 1 over negative 10 to the positive eighth. That's not even close. This number is a tiny, tiny number. 10 to the eighth is a big one. So A is my answer. Number 11. Now with number 11, can't really go through and do like we did with 10, but I can take 5 to the negative fourth power and I can simplify it. I could say, well, I need that to be 5 to the fourth. So instead of it being a numerator, it becomes a denominator. And look at that, it matches D. A couple other things you could think about. My 5 is positive here. Since my 5 is positive, there are no negative numbers my base has no negative attached. So A and C would be out because A and C have this negative. I don't have a negative. I mean, my exponent's negative, but that has nothing to do with my base. So those are some ways that you can eliminate. And 4/5, that doesn't even make sense. Just because I have a 4 and a 5 in my original number doesn't mean it's going to be 4/5. Number 12, evaluate. Well, the first thing I notice is I have 81s here. So that must mean that I'm going to have to, work out these numbers. So keep that in mind. But we'll go ahead and we'll simplify this using our rules. I get 3 to the 2 minus 6, which is 3 to the negative fourth. I don't want anything that's negative on my exponent, so I'm going to make it go from the numerator to the denominator and then make my exponent positive. Now I don't have anything as 3 to the fourth, but I do have all these 81s, so I can assume that 3 to the fourth is 81. And if you check your math, it is. So I'm looking for the option that's 1 over 81. My answer is C. And again, my base number is positive. A negative exponent doesn't mean I have a negative number. The base situation tells me that. So that eliminates A and B right off the bat. Something to keep in mind. 13, which value of n would make the statement true? So this is definitely one of those that you have not seen before, but you know everything you need to know to be able to figure it out. Look at this side for just a second. Don't let that n confuse you. imagine that as a number. If I have a power to a power, what do I do with my exponents? N or not, whether you have a number there or a letter or whatever, what do we do with the exponents? We multiply, right? So I would have 5 to the negative n times 3, right? We multiply our exponents. And that has to equal 5 to the 15th. So couldn't I focus on this part up here? Because my base stays the same. My base stays the same, so truly, all I need is negative n times 3 equals 15. What number must be here? You could substitute the numbers that you have here as an option, or you could solve. Multiplying each side by 1/3 gets me negative n equals 5. If negative n equals 5, then positive n would have to equal negative 5, right? If I find the opposite of each side, that gets me a. The other option would be to substitute. Okay, if you substituted, I would say, well, negative, replace n with a negative 5 times 3. If I put a little 1 here, that gets me 5 times 3, which is 15, and that works out. It's a little tricky, but honestly, with the options that you're given as answers, it's very apparent that the answer here is negative 5. Which is an equivalent form of the fraction. Okay, so again, let's look at the fraction on its own and simplify that down to 1/5. And divide each by 2. Now my x to the 3rd power, there's absolutely nothing wrong with that. X to the 3rd doesn't have to change at all. That stays right up in the numerator where it belongs. This, on the other hand, is a problem. I can't have to the negative any power. So if I want to change y to the negative 2nd power and make it become y to the positive 2nd power, I have to move it from the denominator to the numerator. Move it to the numerator and it becomes the opposite, so y to the 2nd power. B is the only option that fits. And even though it does look a little bit different if we think about it, 5 is the denominator, 1 times anything is itself. So really, this is what I have. (15) Evaluate y over x to the negative 3rd when x equals 2, y equals 4. All we're going to do is substitute. X becomes 2, y becomes 4. Right? I don't really want anything with a negative exponent. So I'm going to take this piece, I'm going to move it up top and make it 2 to the 3rd power. Take that negative, make it positive, and move it. So I get 4 times 2 to the 3rd power. 2 to the 3rd power is 2 times 2 times 2. So really I have 4 times 8. That equals 32. My answer is A. Number 16. Number 16 can be very complicated if you let it be. There's a lot going on, but we'll take it step by step. says select all of the expressions that have a value between 0 and 1. Okay, so think about what that means for a second. Between 0 and 1, so on a number line, if I want something between 0 and 1, this is the area I'm looking at right here. So that means it's going to be positive. So it must be positive and less than 1, right? So it's got to be some sort of fraction. Without any, whole numbers, not improper, that type of thing. So what we'll do is we're going to go through each one and we're going to simplify it till we get a number. And then we'll decide, is that between 0 and 1? Okay, so let's look at A. And we're going to simplify this down until we get a number, and then we'll decide where it goes on if it's between 0 and 1. So there are definitely a few different ways that you can simplify some of these. If we look at A, your first thought might be, oh no, there's fractions. I don't know really what to do. And that's okay. Think about this. When you have something crazy going on inside to the power, think about, could I use that power of a power property? I mean, really, this is 1 to the first power over 4 to the first power. So couldn't I kind of like distribute that 2 inside? And then do the same thing on the second one? One to the fourth over 4 to the fourth. All this is saying is that if I have 1 to the fourth squared, that's saying I have 1 to the fourth times 1 to the fourth, isn't it? 1 times 1, 4 times 4, 1 to the second, 4 to the second. Nothing wrong with what we did there. Just makes it look a little bit easier to handle. Because now if I look at this, I'm multiplying the same base. I can add my exponents, right? I get 1 to the 6th over 4 to the 6th. Well, 1 to the 6th is just 1. 4 to the 6th is some big number, right? Either way, if I have 1 over anything, that's a fraction, isn't it? It's not negative. And because it's a fraction that's not improper, nothing's mixed, that means it's less than 1. If I have a fraction of something, I don't have a whole. So this option is between 0 and 1. It's not negative, and it's less than 1. Let's look at B. Now remember, it says select all of the expressions. So once you get 1, doesn't mean you're finished. Let's look at B. So my base is a -2 for both. So I can subtract my exponents, and I get -2 to the -2nd power. I don't want any negative exponents. I want this to be -2 to the 2nd power, which means I have to move it from a numerator position down to a denominator position. -2 times -2 is +4. I have a positive number, so that means it's bigger than 0. But I have a fraction, less than 1. So that means B is between 0 and 1. On a number line, 1/4 is in between 0 and 1. Look at C. Same base, subtract my exponents. 5 minus -3. Add the opposite, and you get 9 to the 8th. That's a really big number. Definitely bigger than 1. C is out. Now, another way you could have handled that, if you like dealing with the negative exponents, I could have taken and moved 9 to the positive third to the top, and I would have had 9 to the 5th times 9 to the 3rd. That equals 9 to the 8th, which is what I had before, which is still a really big number, and it's not one of my answers. Now for D, same base that we're multiplying, so we're going to add our exponents. I get 5 to the negative 3, which becomes 1 over 5 to the 3rd. Remember, I want that negative 3 to become a positive 3. So I'd move it down and make it 5 to the 3rd, right? 1 over 5 to the 3rd is 1 over some big number. It's definitely positive, and it's not mixed or improper, so this would be between 0 and 1. If you want to get technical, it's 225, I believe. Or 125, I guess. Either way, it's definitely not negative, and it's definitely not bigger than 1. This is a tough one. It's worth more points, so definitely take your time. Now our review. Remember, with repeated decimals, if I have 2 digits repeating, I'm going to put it over 99 because it's the hundredths place. And through that formula that we did, it ends up being hundredths place minus 1 is 99. So I drop my decimal, write the digits that repeated as my numerator, 99 in the denominator, and I simplify. Get 18 over 33, simplifies to 6/11. And finally, solving my equation here. Do a little review, add the opposite first. We need to simplify the left-hand side, following the order of operations. I can't add inside my parentheses, but I can distribute. Negative 2 times 3x is negative 6x. Negative 2 times negative 5 is positive 10. Still not done simplifying on the left. I have an x and more x's, so negative 6x plus positive 4x is negative 2x. Now I can start solving because my left side is simplified. And I end up with x equals negative 3/2. And that's just long-term review. This is something that you definitely need to continue practicing, but that's it.